Okay, and now it's starting. Okay, and assume that we'll see all the participants on numbers rising up. 17 right now, rising up.
Okay.
Come on.
Okay. Okay, we're ready to start whenever you are.
Sure. Good morning, good afternoon, good evening. Welcome to all of you who are on the other side, our audience, PNI Madrid chapter, our allies chapters in Latin America, Buenos Aires, Nuevo Cuyo, Montevideo, El Salvador, Cajamarca, Santa Cruz in Bolivia, Asunción, Peru, Venezuela, Guatemala, Córdoba in Argentina, and also Quito. We also welcome the remaining chapters in Latin America invited to this presentation, and all of you who are listening from Spain and from any corner of the world. We appreciate your interest and assistance. And on Refe Pagan, volunteer at the Buenos Aires area, and together with our area manager, Jesus Vázquez, and our fellow Jose Barato, Fernando Muñoz, Luis Reyes, and Cristina Fernandez, we are pleased to present the interesting presentation of Ronald Schmelzer and Kathleen Walch, how to run a successful AI project and avoid failure. First of all, many thanks, Ron and Kathleen, by your cooperation and for sharing your experience and knowledge with the subject as you present today. We are now registered 120 attendees to the presentation from different countries. Thank you again very much. Despite the buzz around AI and its potential to revolutionise industries, a surprising 70 to 80% of AI projects fail. Why do so many AI initiatives brimming with promise and potential end up failing short? This is the question. In this talk, Ron and Kathleen explore the top reasons for these AI project failures through real-world experiences and read from the headlines examples. We'll share why many AI projects fail and the practical ways to navigate these challenges for AI project success, highlighting the project manager's role in AI projects. Furthermore, we'll explain how emerging approaches to strategic AI are helping to address a wide range of ethical and responsible AI challenges. Our speaker, Ronald, is the managing partner and founder of Cognilytica. He co-developed the Cognitive Project Management for AI, CPMAI methodology, used by Fortune 1000 firms and government and agencies worldwide. Ron is a CPNA Plus E certified and a lead instructor on CPMAI courses. He is sought-after expert on AI and data best practices, co-host of the AI Today podcast, Forbes contributor, Tech Charges AI columnist, and SXSW Innovative Award judge. A lot of badges he holds. Is also a BS in computer science and electrical engineer from MIT and an MBA from Japan University. Kathleen Walch is the managing partner and founder of Cognilytica, where she co-developed the Cognitive Project Management for AI, CPMAI methodology used by Fortune 1000 and a lot of different governments. Just a key note here, remember, guys, friends, CPMAI is becoming the standard for AI project management best practices. Kathleen is also the CPMAI Plus E certified. Let's start on this certification courses. Is also graduated from Loyola University with a degree in marketing. I want to remember you that with this assistant, you will obtain one PDU. Being the report of this PDU under your responsibility, will send you anyway a code with the necessary instructions for reporting the PDU to PNI. You can leave your question in the platform. So Ron and Kathleen, they will answer at the end of meanwhile the presentation. And also you will have soon the record of the webinar available on YouTube and also through our PNI Madrid chapter. Without any further delay, I will leave you in company with Ron and Kathleen. Go ahead, my friends.
All right, well, thank you so much. And we are so excited to be presenting today on how to run successful AI projects and avoid failure. So I know that you had an introduction of us, and thank you so much for that. We do want to just have a few housekeeping items before we go ahead and get started. If you would like closed captioning on, I encourage you to do that. Make sure that it's set to English so that you can see that as we are talking. In case English, I'm assuming it's not everybody's first language, so we will try and talk slow, but if you want that closed captioning, that will help. And also, as far as questions go, please type in your questions in the Q&A chat window throughout the presentation. We'll monitor them throughout, and if it's important to answer that question during that slide, we absolutely will in case you want clarification or it's relevant to that topic. Otherwise, we'll address questions at the end. So with that, we just wanted to quickly introduce ourselves again, and then we'll go ahead and get started. I'm Kathleen Walch. I'm a managing partner here at Cognilytica. We're an AI-focused research, advisory, and education firm, and I'm joined by my colleague, Ron Schmelzer. We are both contributing writers to Forbes and Tech Target, and we have a very popular podcast called AI Today. We've been doing that since 2017, so now we're on season 7, coming up on season 8, and I encourage you to listen to it. We go over various topics on AI today. It's how to think about it. We just wrapped up a soft skills series on AI, especially when it comes to generative AI. We also have a big popular AI use case series about how it's being applied to different industries, a trustworthy AI series, and many more. So I encourage you to listen to it if you haven't. But with that, we're going to get started.
Yes, and welcome everybody. I'm Ron Schmelzer, also a managing partner here at Cognilytica. And really, we've spent all of these years since 2017 talking about implementation of AI in the enterprise because AI is a tool. It's a technology. That's all it is. It's up to us to make it do what we want it to do. Well, that's until the robots take over, but that's a whole other story, which we will not talk about because in the meantime, 80% of these projects that we're putting AI into, more than 80% are failing. And by failing, of course, we mean they're not delivering what people expect. They're being canceled in terms of projects, or they're being put into very limited use. And there's a couple of reasons why, well, there's actually many reasons why these AI projects are failing. We're going to be sharing with you those insights here in this presentation. But the first and foremost reason why these AI projects are failing is because AI projects, even though AI is a technology and it's implemented using computing and IT and software, AI projects are really not like traditional software projects at all. Because what we're really trying to get machines to do is solve a lot of the problems that we would otherwise have people do. This is what artificial intelligence is all about. It's not just programming machines to do what we ask them to do. That's human intelligence. If we want machines to be intelligent, we want them to do the things that otherwise people are using their skills. And if you're not familiar with the ideas of just intelligence in general, we generally refer to these ideas of intelligence as the 3 P's of intelligence. That is perception, which is the ability to understand the world around us. Prediction, which is understanding what might happen next in terms of that world and the various senses we have. And then, of course, planning, which is determining what steps to take given our perception of the world and given what we are perceiving in terms of predicting what might happen next. This is where we need machines to get more intelligent because we usually do programming when the machine can't do those things on their own. But it turns out that when we do ask machines to do those things, we're really talking about very different applications of AI. Even though they're all fall under that general umbrella of AI, they're really very different things. And this is the core idea behind the 7 patterns of AI.
Exactly. So we looked at all these different AI projects and said, well, AI is an umbrella term, but what we're trying to do is different. So if we're doing a recognition pattern, for example, then we may select different algorithms and need different data, and the length and timeline of our project, especially to see ROI, may be different than if we are implementing a chatbot. So we broke it down and we said, okay, what are these projects trying to do? All these AI projects we were looking at, and they fall into one or more of the 7 patterns of AI. And it really is a great way for you to understand what you're trying to do, because then when you identify which pattern or patterns of AI you're going to be doing, it can help shortcut your way to project success. So we present it as a wheel because no one is more important than the other. So starting in no particular order, we'll start with hyper-personalization. So the goal of hyper-personalization is to treat each individual as an individual. So you can think about this as a marketer's dream, right? You're able to get the right message to the right person at the right time. But you can also have hyper-personalized healthcare, or hyper-personalized finance, or hyper-personalized education, where you're able, to have each student or each learner at your organization really have a personalized path. The recognition pattern is making sense of unstructured data. So if you think about all the data you have at your organization, probably 80+% of that data is going to be unstructured. So we think about emails and voicemails and images and all of that data that's not in, a well-defined schema. So our recognition pattern makes sense of that unstructured data. An example here would be facial recognition, for example. Then we have our conversation and human interaction pattern. So this is machines and humans talking to each other in the language of humans. So we think about this with chatbots, for example. Also, when we think about large language models, maybe ChatGPT, for example, that would fall in the conversational pattern. Then we have predictive analytics and decision support. So this is taking past or current data and helping humans make better decisions. We're not trying to replace the human in this pattern. We're just using it to augment what the human does. Then we have goal-driven systems. So this is really around reinforcement learning. And the idea is to help, find the optimal solution to your problem. So we think about a mouse going through a maze. How do you find the optimal path to get to the end goal? We see this also with resource optimization, or with, if you have to map out a route, then this is a great this is a pattern for that. Then we have the autonomous systems pattern. So the goal here is to remove the human from the loop. Whenever you're removing the human from the loop, that obviously is going to be incredibly difficult. So this is the hardest pattern to implement. We can think about this as both hardware and software. So we can have autonomous systems, the hardware systems, we think about autonomous vehicles, but we can also have autonomous business processes. And then the last is patterns and anomalies. So machines are really good at looking at large amounts of data very quickly, being able to spot patterns in that data, and also being able to spot outliers or anomalies in that data. We think about an example here being fraud detection. So when we think about the 7 patterns of AI, it really helps us, break it down one level deeper. And rather than just saying that umbrella term of AI, we can say what pattern we're actually focusing on.
I think that's the biggest part, because when people are talking about they're implementing an AI project, the kind of project really matters. All these projects are not the same, as you can already tell. Now, with generative AI and large language models, implementing a conversational AI project is actually really easy. Now, 5 or 6 years ago, it was actually much harder. You had to build your own language model. You had to build your own system for handling inputs and outputs. And usually they were very restricted. They were chatbots that can only answer questions about very specific things that the model was trained on. Now we have these very large language models that are based on foundation models that have been trained on literally the whole internet. And so implementing a conversational pattern is really trivial. You can even do it in a matter of minutes now. However, that doesn't mean building an autonomous system is any easier. That's still a hard problem. Or building a hyper-personalization project, or any of these other patterns. So the first thing you have to do when you're implementing AI is determine what pattern you're solving. And that pattern will help determine how complicated the project is and how much data you need and the algorithms and all the other things that Kathleen mentioned. So there's a second part to here, is that when we think about those patterns, some of these patterns take longer to implement, are harder to implement, require more data, have more risks than others. And sometimes the return that we get after taking all those risks, there's not enough juice left to squeeze. As we said, the juice is not worth the squeeze. We don't get enough benefit of that. And we see that a lot because people are very tempted to implement AI, but they don't know what problem they're solving. And if they do know what problem they're solving, AI is not necessarily an optimal solution for that problem. So there are a couple of good points here. So the first is that people fall in love with AI and they see that they can do some simple task like generating emails or something. And then all of a sudden they think, well, I can do everything with AI. And then they try to do that and it doesn't really work very well. People are complaining, oh my goodness, I asked ChatGPT a math question and it got the math question wrong. Well, the answer is, of course it did, because a ChatGPT is just a large language model. All it does is tries to predict what the next token is. It doesn't try to actually understand math terms. We'll come up on this later when we talk about a different failure mode. But here in this case, the issue is that sometimes people try to combine too many patterns together. So there's an example here we provide from the real world where a Walmart, a large retailer in the United States, wanted to implement a robot to scan the shelves to basically count inventory to see how much stock they had and what needed to be restocked from the back, or keep track to make sure things weren't lost or misplaced in the wrong place. And what they were doing is they were, of course, replacing people who might have taken all day and maybe multiple days to count the inventory in stock. And they thought, well, let's build a robot that can walk around, navigate all the store shelves by itself, and then scan the store shelves to determine what the inventory is and compare that against the count. Now, it turns out, well, I could say, well, they were using AI for this, but were they doing one pattern or multiple patterns? Well, it turns out they were doing multiple patterns. One of those patterns is the recognition pattern, where it was going to use a camera with the light and to detect what's on the shelf and then do a count. And then the second one was the autonomous pattern, which is the ability to go around and navigate and drive up and down the store shelves. Now we mentioned that autonomous systems are some of the hardest. They take their most complicated, highest risk, have to be most accurate, most difficult to do, too many variables in the real world that get in the way of it, whereas the recognition pattern is actually fairly easy to do. Well, here you see from this example, Walmart had to actually cancel their project and they went back to humans because they spent so much time and so much effort trying to get the systems to work. And we know that autonomous systems have a lot of failures. They said it wasn't really worth it. Now, what they should have done, if they were using a methodology that would have helped them identify, is they should have realized they were doing multiple patterns. And instead of doing these two patterns, they could have done just one. They could have picked the easier pattern, which of course is the recognition pattern. And instead of having the robot navigate by itself, they could have put a camera on a shopping cart and just had a person pushing the shopping cart down the aisle. And the camera would have been very fast. It would have counted everything. And the human would have been easy. They could have just walked down the store shelf and they could have implemented it very quickly. It would have been very cost effective and it would have probably reduced the time. So it would have provided the return that they were looking for at a very low cost, which would have meant a very high ROI. So because they weren't thinking about the patterns and they weren't breaking it down, they had this high rate and chance of failure. And of course, in this case, the project did fail.
Exactly. So we always say these projects are not going to be free. So make sure that your return on your investment is higher. Otherwise, we see a lot of projects failing. Another reason that we see projects fail is around data issues, both data quantity and data quality issues. So the amount that you have and then how good your data is. We always say data is the heart of AI. And so these are data projects. So you need to make sure that you're running them as such and following best practices methodologies around data projects. So when we talk about data quantity, then we need to say, well, how much data do we need? And the answer is, it depends. You need to go back and look at which pattern of AI you're implementing, and that's going to help determine how much data you need and how much data you're going to need internally versus being able to acquire third-party data. So if we think about chatbots, for example, well, you're probably, we always say, think big, start small, and iterate often. If you're not answering lots of different questions, you're just, focused on the amount of questions that you're going to be answering, then you don't need that much data. And if you're doing a recognition pattern, there's a lot of third-party models that you can use, and there's a lot of also third-party image repositories that you can use. So you don't need to be getting that data yourself. But for autonomous vehicles, maybe you're going to need more data. So it depends on the pattern that you're trying to solve to figure out the amount of data that you need. And then the most important thing too is the quality of your data, because as the saying goes, garbage in is garbage out. So if you have bad data that you're using to train your AI systems, then expect your results to be bad, right? So we always have to weigh the two options to say, how much data do we need, and understand that that data, there is a cost to that data. So you don't just want to say the more data, the better, because you do need to make sure then that it is clean, that it is good quality data, that it's relevant data. So there's a lot of different things that you need to pay attention to. We always like to have rip from the headline examples. So we presented on the retailer Walmart. But we also here, it's important to note that companies that can still get into a lot of trouble. So the image we have at the bottom is an image of a deer, and it was mislabeled a magpie. And a very popular image repository, ImageNet, has about 5% of their data is mislabeled. And so this goes into the data quality issues, right? And you don't always have visibility into that. So you need to be mindful, because if you're doing deer recognition and it's mislabeled, then you're not going to get good results. We also had a retailer in the United States, Rite Aid, that was banned from using facial recognition, AI facial recognition, for 5 years after it was determined that their technology was falsely tagging customers as shoplifters. So they used images from their video surveillance. And if anybody has looked at that, you know that it's not great quality, right? It can be grainy, it's black and white. It may not always have the most optimal view of people's faces. And so they got into a lot of trouble, both for using that, poor quality images that was falsely tagging customers as shoplifters, and also they were not educating the employees at the store on how best to go about approaching the issue if somebody was potentially tagged. So we do like to bring these up, and we will have a lot more throughout the presentation to say this is still happening. It is an issue, and we want to identify it and present it so that you can understand what's going wrong to not make these same mistakes yourself.
So yeah, you might be thinking, as you said, more data is better, but of course, more data, more problems. And part of that is realizing the amount of time that people spend on the projects. You might think, well, on an AI project, I'm spending all of my time making the machine learning model, doing the training, doing the model testing. No, you're actually spending a very small percentage of the time on your project on those things. You're spending almost more than 80% of your time on data. Getting the data, collecting the data, cleaning data, augmenting the data with extra things that you need for the machine learning system, deduping, prepping, all this sort of stuff. And that's where you spend most of your time. And if you know that you're spending 80% of your project on data engineering, it's one thing to say I have a gigabyte of data to clean. It's another thing to say I have a petabyte of data to clean. All of a sudden, your small project goes to being a big project. And it's not because the model is any more complicated or the use case is more difficult or the scope is larger. It's just because you put more data. And even if the scope stays the same, if you're saying, well, more data is better, so let me collect every bit of data in the enterprise, you're just making your project a lot more complicated. And what ends up happening is people tend to shortcut that process, because data engineering, unless you really love it, is not fun. Cleaning data is not fun. Collecting data, dealing with security permissions, dealing with inconsistencies. One database has data that looks like this. Another database has the same data, but in a different state. And then you have to reconcile. Oh my, it's a headache, right? This is where the projects get stuck. And if you say, well, forget it, I'm just going to either use a small amount of data and it doesn't work, or I'm just going to use the data anyways, but garbage in is garbage out, this is where projects fail. So you have to respect the data process, which means limiting the scope not only of the project, but also limiting the scope of the data that's in it. This actually relates a little bit to one of the other failure reasons for AI, and that's called the proof of concept trap, which is that it's actually really easy with AI to test an idea because the models are available, they're becoming lower and lower cost, some cases even free, and you can test something really, really small really quickly. And it may not be doing anything that useful, but you could say, oh, I got it to answer all these questions. Now let's build a chatbot. But of course, the chatbot is failing where your simple little Q&A system on ChatGPT is working. What's the difference? Well, the difference is that you weren't actually proving anything with the proof of concept. The proof of concept was just, can you experiment with the technology and do something not that useful, even though it may be interesting. but it's really, you need to do a pilot. A pilot is where you test something in the real world, and all the difficulties come in the real world. And this relates to the data issue, because you may be tempted to say, oh my goodness, the real world has all this data. I don't have time for that. So let me test something really small with some small data set that's really controlled. And then you can say this works. But then you try it in the real world and it doesn't work, because that small data set wasn't representative of anything. It was just the smallest data set that you could clean in the amount of time that you had and the amount of money that you had and the resources you had. So we tell people it's a trap to basically say, well, we're going to do a proof of concept. And then after the proof of concept, we'll do the implementation. And we say, you might as well just throw away the proof of concept, because you're just wasting time and wasting energy. Even if it succeeds, it doesn't actually do anything for you. And you might as well just not waste your time at all. You focus on a real world pilot using real world data with a real world problem with real world customers and users and things like that.
Exactly. And we say proof of concepts usually prove nothing. And we actually have an podcast. It's either just published or it will be upcoming very soon. So I encourage you to go to AI Today so you can dig deeper into that if you're interested in one of these failure reasons. But we always say definitely start with the pilot whenever you can. And a lot of these failure series go into each other, right? They're not all very unique. They usually come for a variety of different reasons. Another reason that we see a lot of AI projects fail is that the real world just doesn't match your model. And again, that's why we want to be going and doing pilots rather than proof of concepts, because we want to see how these are being used in the real world. We have an example here with Andrew Ng, who is an AI luminary, and he has been in this space for a long time and has done a number of different projects. But this project in particular that we are going to be presenting on ended up being a failure, because what they were doing is they said, let's figure out how we can have AI images, how we can have an AI system read radiology images so that it can be an extra set of eyes and it can, help the radiologists do their job better. And so they started out with Stanford Medical Hospital, their images, which had high quality machines, which produced high quality images, really state-of-the-art everything. And what they found out when they tried to bring this now to other hospitals, it turns out that when you take that same model, that same AI system to an older hospital down the street with an older machine, and the technician uses a slightly different imaging protocol, that data drifts to cause the performance of the AI system to degrade significantly. In contrast, any human radiologist can walk down the street to the older hospital and do just fine. So what we recommend here is that if you know that you are going to be using whatever it is that you build on different systems, in this particular example, it was recognition pattern that they were doing, then don't start with the best high quality data that you have. Maybe start with the, data that isn't as good quality, and that the images were maybe a little grainier and the imaging protocol was slightly different. This is also where you want to make sure that your data is representative of what it is that you're trying to do. And so that's why it is so important, if they had started this in a pilot and been testing it at different facilities, they would have understood, hey, if there's some problems going on, let's figure this out. And that's why you always want to make sure that the real world matches your model and that you are understanding where your model is going to be implemented and make sure that it works there.
And this relates to another failure reason, which is that, let's just say you have built an AI project and solved a real problem. So you haven't fallen into the first trap, which is that you actually have a good problem that you're solving, that you're not treating it like an application, you're actually treating it like a data project. You found one pattern to implement and you've limited the scope of the data so that it's something that's the right data. You've even cleaned it up so it's all good. And you're going to do a real world project. So let's say we're going to do this inventory management thing, and I've limited it to just say the inventory for a couple of shelves, because maybe those are the ones that have the most issues with inventory. And so I only need to collect the data that's for those shelves. I don't need to collect data for every product and every image for every product. And maybe I can even get the images that are similar, and I tested it, and I'm going to do it as a real world pilot. So I'm actually going to have my employees actually using the cart every week or so to do the counts. So it's a good thing. Am I out of the, have I filled all the problems? The answer is no, because the next thing is that you might have think that you're done. And the problem with AI projects is there's no such thing as set it and forget it. There's no such thing as, well, the model's working now, it'll work forever. And I think the problem is that people realize that AI systems are what are called probabilistic systems. They're not deterministic systems. So in a deterministic system, like a program or a flow chart or a rules-based system, you can say, if this is the input, this is the output. And as long as you always have that same input, you will always get that same output, or you'll have very well-defined flows. You know, they click on this button, they select this option. I mean, websites and, rules-based, they're very deterministic. They should always happen in a very reliable flow. However, AI systems are trained on data. They're not programmed. They learn from data, and they learn in probabilistic ways. So when people have a conversation with an LLM, they're not always having the same conversation. The inputs are never the same. The outputs are never the same. And there's no guarantee that they will even be always reliable. So that means there's always a chance that you will get undesirable results. You will get things that are not correct, And this is the case of, doesn't matter how well the chatbot was trained, there's always it's not a guaranteed 100% chance it'll always work. There's always that percentage. Now you can try to get it as close to 100%, but it will never be 100%. So this is the risk involved. If you just set things out and you forget it, problems will happen. So not too long ago, a company, airline company, Air Canada, got into trouble because they put a chatbot on their website powered by an LLM, where it would just answer any question that people had, and it would reference the materials that Air Canada had made available. But of course, as we know, LLMs are always happy to give you an answer no matter what, even if they don't have sufficient information. So in this particular case, a customer had asked what Air Canada's policy was for a death in the family, about whether they can be, if they can get a refund if there was some case where there was some issue around what's called the bereavement policy. And they asked this to the chatbot, and the chatbot said, yes, in this situation, you can get a refund. So if you buy your ticket in advance, but you have to cancel it or change it, then we're happy to offer a refund. Now, of course, that was the wrong answer, because on the Air Canada website, the website said that there was no policy for a refund, and you may not get a refund in that situation. So the customer actually took Air Canada to court because Air Canada would not issue the refund, and the customer won. They beat Air Canada because Air Canada, their argument was that the chatbot was not the authoritative source of information, that the website was the authoritative source of information, and that somehow, I guess, the customer should know when they're talking to the chatbot, that the chatbot could make things up. But that's not a valid argument, because if you have a chatbot and you put it there for a purpose, this purpose is to answer questions, why would you say, I'm going to answer questions but don't believe the answers? No one would do that. That would make the chatbot useless. Or what they could have done is they could have put a disclaimer that said, please verify any answers against the website if it has to do with refunds or pricing or something like that. Or they could have just somehow trained the chatbot to not answer any questions with pricing or refunds. They didn't do either of those things, which is another mistake. But the big mistake is that they basically just set it and forget it. They just put it in and they say, well, what could go wrong? Let's just leave it there. What could go wrong? And the answer is a lot. And if there's no human in the loop, if there's no constant monitoring, there's no constant management, if there's no way to know when people are getting different answers than the website, then one day you too will be surprised when someone does something and then you get sued or some other problem that happens.
Exactly. So, we always say keep a human in the loop, make sure that you're constantly monitoring this. And then also, again, we always say think big, start small, and iterate often. So rather than putting a chatbot on the website that was able to answer a variety of different questions all at once, hundreds, thousands of questions all at once, just start with the most frequently asked question that you want to alleviate, whatever that is. You want to alleviate call center volume. You want to alleviate frustration with your customers. You want to be able to provide immediate answers. You determine whatever that is for your organization, and you have the chatbot just answer that one question. And then once you've proven that there is a return on investment, right? A positive return on investment, you can have it answer another question and continue to grow the body of questions it's able to answer. So another issue that we see is falling for vendor hype and also product mismatch. And sometimes there's overhype and overselling of different products. So for a variety of different reasons, AI is really moving fast. And what an organization, what one vendor has now versus 6 months from now may change quite a bit and may change for the better and add and enhance a lot of different product features. So to be able to say what's going to happen 6 months from now is really hard. But what we see is that for a number of different reasons, organizations are told that they are in X shop and you insert whatever vendor that is, and you only can buy different solutions from that vendor. And they may be really wonderful solutions, but they're not the best solution for your problem. So we always say you really need to always understand what problem you're trying to solve. That needs to be the first question that you ask. And then you say, okay, is that problem is AI a good solution to that problem? And if it is, now you can go out and say, okay, what is the vendor? What is the tool? What is the solution that I need to be able to solve that problem? What we see far too often is you're trying to fit that vendor square peg into a round hole. So you're trying to fit those vendor solutions that either you currently have at your organization or that you're that vendor X shop, and whatever vendor solutions that they have, you're trying to fit to your problem. And it doesn't always work. So that's where we see a lot of problems. We always say it's people, process, and technology. And technology is usually the easiest problem to solve. And because of that, people continue to buy more technology to solve the problem when it isn't always the case. So that is another issue that we see, and far too often we continue to see that. And so we say, just, really understand the problem that you're trying to solve, and then make sure that the solutions and, whatever vendor solutions people are coming at you with, make sure that it really is solving your problem.
Yeah, there's another sort of related issue here, which has to do with the fact that a lot of times people aren't entirely sure what they need from these products at all. Because the issue is that, one, the space of AI is moving very fast. As you may say, it seems like every day there's a new iteration of some new model, some new capability. It's doing something great. And here you are trying to buy a solution. So you have to try to predict in many ways what you need, not only now, but in the future, and not be locked into a decision, because 2 months from now, there might be some new model that may make the thing you just bought obsolete, or the thing you bought might not be that good. So it's very difficult actually right now to make a buying decision, a long-term buying decision, even a medium-term buying decision when it comes to AI products. So I think the biggest thing is trying to be as vendor neutral as possible. We say try to not be so focused on whatever the implementation is, because I guarantee you tomorrow, the day after, something better will come about or something different will come about. And if you're constantly chasing it, you will never win. So you have to sort of stay as flexible as possible, stay as uncommitted as possible, if that's even possible. And the other thing I mentioned earlier was that sometimes we are applying the wrong technology to the wrong problem, or applying doing the wrong thing. Where, as I said, people are trying to do math problems with LLMs, but LLMs just predict the next word. So it doesn't even think of numbers as numbers. It thinks of numbers as word tokens, and it just tries to predict what next word it comes in the sentence. If the sentence is 3 + 5 + 10 + 12, it tries to say, well, looking at the internet, what does the internet predict the next word might be? Well, it doesn't mean it's actually doing math, and it probably will get it wrong. That's why they hallucinate, because they predict based on what the text are. It doesn't actually understand what these things are. That's another AI Today podcast topic where we talk about this missing level of understanding. We're not going to just go from pattern recognition to super intelligence like that. Speaking of super intelligence, we'll talk about another uniquely AI failure mode, and this thing called the uncanny valley. So if you're not familiar with the idea of the uncanny valley, it's this idea that as you take something which has no human-like or no animal-like features at all, and you increasingly add more anthropomorphic, animal and human-like features to them, at first they become kind of you have a positive reaction. You have, oh, that's nice. I have a toaster, just a regular toaster oven, not very interesting, but I put cute googly eyes on there. That's kind of cute. Maybe you put some kitty ears on there. Oh, that's kind of a cute, very interesting little, toaster oven. But the more you start to make it more human-like, you give it more human-like features, the more people are like, wait a second, this is kind of creepy. And so they get this negative reaction to this, and the thing is just not even human-like at all. It's just a device. It's just a piece of technology. You shouldn't be feeling positive or negative about it. It's just a technology, but people do feel negative if it becomes too anthropomorphic. This is why people don't like robots that look too human-like, but they aren't human. It creeps them out. So this uncanny valley is this dip in positive sentiment or dip in sentiment towards things that look close to, but not exactly human. People don't like it. And it turns out that this is not just an issue with robots and things like that, hardware. This is also an issue with data. That as you start collecting more data, in the beginning, if you have a website that's doing e-commerce and it doesn't know anything about you, there's no account information, no purchase history, you're like, okay, that's okay, but not that great. But if I have some personalization features, so it knows what to recommend, it can recommend products based on what other people like, so it keeps track of those people too, you might have a more positive feeling. It's like, oh, it's recommending good products. As we add more data, it gets more value. But at some point, we add too much data. We get this creepy feeling also with data. We're like, oh my goodness, now you know too much about me, my life, other people. It's starting to make recommendations about observations that I didn't even think it should even know about, or it's sharing my data in ways that I don't like. And it's the same negative sentiment. People will feel negatively about an application, about a product, about a project if people know and are aware of the fact that you're collecting too much information about them, too much data, and you're using it to train these AI models, and people get creeped out. And we're starting to already see that. People are saying, I'm not going to use that AI because I'm training the AI with my personal data. I don't like that it's using my emails. I don't like that it's using my interactions. Well, people are going to not use it. And if you have an AI project that depends too much on this personal data, you will find that people will not interact with it at all. So it'll be a failure, and you may even get a lot of resistance. You may even get some public resistance from people saying that this application is too creepy and it's collecting too much data. Does that mean it's a failure or that it doesn't actually work? The product might work great. It may be a great capability, but because you've crossed that line, people are uncomfortable with it.
Exactly. And what's important to understand with the uncanny valley is that once you go into the uncanny valley, it's very hard to near impossible to get out of that. So you don't want to be losing trust with your customers. Like Ron said, you can have a technically successful implementation, but an adoption-wise unsuccessful implementation, which if nobody's using it, then it's really not successful. Also, unfortunately, everybody's uncanny valley line is different. So you want to get right up to the line without going under it for the majority of folks. And that is something that you're going to have to determine case by case. A big overarching reason that we see why AI projects fail is this idea of overpromising on what AI can do and then under-delivering on the results. So we've been here before. For anybody that has been following AI and the history of AI, you know that the term itself was coined in 1956. So the term has been around now for a number of decades, and it is not new. But we've gone into two previous AI winters, which is a period of decline in investment, decline in adoption and funding and research, where organizations just use different technology in different ways to get to their end goal. So we really want to be mindful. And the big overarching reason why we've had these two AI winters in the past is because we overpromise on what AI can do. People get really excited about AI technology based on movies and science fiction and books that they read. And so they get really excited about what could happen, but then they under-deliver. We're not really there yet with the technology, and that's for a number of different reasons. Ron brought up earlier, we talk about the DIKUW pyramid a lot, which data is at the bottom, then information, knowledge, which is where we are now, that's machine learning. Then we have understanding, which is machine reasoning, which we are not there yet. And then wisdom, you think about, human level intelligence. So we really need to be asking ourselves, when we're thinking about using AI and have AI projects, why are we using AI? What problem are we trying to solve? Are we promising too much from that AI solution? Do we want to have, as Ron mentioned, a lot of people ask ChatGPT math questions, and that's not the purpose of that. So it can really, help augment and enhance your writing capabilities if you want to have, help with marketing, writing blog posts, helping with a number of different things, but you really have to understand the use case for it. You also should go back to the 7 patterns of AI and say, is my problem falling into one or more of these 7 patterns? Are you more invested in doing AI than solving the problem? For a number of different reasons, organizations are saying, I'm feeling so much pressure externally, internally to be doing AI, do AI, whatever that means. So we just need to do it. And are you more invested in doing AI than actually solving a problem? Because if you're not going to see that return on investment, you're going to be spending all this money, time, and resources only for your project to really not show success, then it's not going to be a win. It will be a failure. Do you even know what problem you're trying to solve? So that's really important. You need to say, what business problem am I actually solving? Don't just have it be a very, superficial problem. Have it be an actual real problem that you're trying to solve where you can see real benefit. And are you tackling the hardest possible problem first? When we go back to the 7 patterns of AI, we say conversational systems, they're pretty easy to implement. Go ahead and do that. Maybe predictive analytics, you can get a lot of benefit right now. The patterns and anomaly detection, you can get a lot of benefit right now. The autonomous pattern, that is the hardest problem. That is the hardest pattern. So if that's what you need to do, okay, maybe that is what you need to do, but is there something else that you can start with first? And if you are tackling the hardest problem first, it's going to cost a lot of time, money, and resources, and your chance of failure can be high. And so we also say, don't tackle too many problems at once. Again, that think big, start small, and iterate often. The Walmart example, we said, start with just the recognition pattern. Make sure that that is providing that return on investment that you're looking for. Make sure it's actually working as intended. And then if it's, getting to the point where humans, it doesn't make sense for them to be walking the floor anymore with the, camera, then you can bring in the autonomous pattern. But don't try and tackle too many patterns at once. It's going to make your project overly complicated. Your scope can really, get out of control, and your chance of failure is really high. So we bring up the example of the self-driving Uber car that a few years ago, Uber was, really moving forward with self-driving vehicles. And unfortunately, their Uber vehicle hit and killed a pedestrian that was walking in the middle of the street. So we say, and now they've really killed the whole self-driving project because of this fatality. So we say you're starting with the hardest possible problem here. And what problem were you actually really trying to solve? Yes, you were trying to have cars drive themselves, but is that really just doing AI rather than actually solving a problem? Because there's other ways to have people get around rather than self-driving vehicles, maybe public transportation or having the human drive the Uber. So we do need to be mindful and really ask ourselves all these questions so that we aren't over-promising and under-delivering with AI.
Yeah. So, of course, we talk about these challenges, but of course, there are solutions. And as Kathleen mentioned at the very beginning of this whole presentation, we have 3 things that we need to make any sort of technology project work. Of course, we need the technology, but technology won't do anything by itself. And of course, we just saw many examples of applying technology the wrong way. So even having the technology, even having the best technology doesn't do anything for you. Likewise, we have the other parts. We have people as well. Well, we need people to implement technology, but you could even see issues around having the best people, even the best. Andrew Ng, we showed Andrew Ng, who is one of the most notable people in this space. We also have great companies, Walmart, Amazon, Microsoft, IBM. These companies all have some of the best people as well, in addition to the best technology. But we just showed you failures with IBM, with Microsoft. We didn't show you the ones from Amazon, but trust me, there are plenty, and Walmart. So this brings us to the third leg, which is process. People, process, and technology. And process is usually the part that is the most missing in AI projects. And even on the people part, it's giving people the right method, right framework. So one of the things that was developed quite a few years ago, actually many decades ago, was a methodology for doing data projects called CRISP-DM. And what evolved out of that was as people started to realize that AI projects are basically big data projects. We're just, in effect, what we're doing is we're training machines on data, and then we're learning patterns from data, and then we're going to apply those patterns to any of these patterns of AI. So we learned a pattern. It's like, well, maybe we need to use it for recognition. We learn a pattern. Maybe we need to use it for conversation. That's why the core of all AI is machine learning at the moment, because that's where the current level of intelligence we're trying to solve is this K knowledge level, which is trying to identify and spot patterns. We may not understand what the machines may not understand those patterns, but they can at least spot the patterns and they can repeat the patterns. And those patterns might be really useful for object detection, for facial recognition, for content generation, for predictive analytics, for any of those patterns that we just talked about, autonomous systems. But if we're based on these data projects, we need to basically run our systems such that they are data-centric. So the CPMAI methodology, which is called the Cognitive Project Management for AI methodology, basically builds upon CRISP-DM and it builds upon agile methods that are data-centric. And the idea is that we can think about these 6 phases of each iteration. So every time we're building an AI project, we're going through a full iteration here to say, what problem am I trying to solve? That's my business understanding. What pattern, is this an AI specific problem or is this a non-AI problem? Which parts are AI? Then I could say, which pattern of AI am I doing? And I can even answer things like the AI go, no go, which talks about the various different things to consider. Then once I know what problem I'm solving, I can scope it and then try to only get the data that I need that's necessary, not just for the problem, but for that particular scope. And now I know more data, more problems, because I have to spend 80% of my time on the data side, not on the fun parts of building the AI system. So that means I'm trying to narrow the scope, reduce the scope, limit the amount of data. Once I have it, I know garbage in is garbage out. So the next thing I need to do is prepare that data. So I haven't even built the AI system yet. I've really just identified my business problems and then identify what data I need to solve it. And then I'm getting that data ready so that by the time I have my data ready, then I can build the model based on the problem that I know I'm solving with the data that I know I have that's already clean. And then I can evaluate to see whether that model is actually going to work in the real world. So I'm not going to do a proof of concept. I'm going to do a pilot, which means that I want to find the smallest problem that I can solve with the data that I have, with a real business problem that I actually deliver a real return. And then I could think about putting that model into the real world, but I can't stop looking at it because there's no such thing as set it and forget it. So we could do all this iteration. The idea is to do this as quickly as possible. So this big idea of think big. So what is the problem you're trying to solve? Start small, pick the smallest problem that has the greatest ROI, focusing on the data that you have and the success criteria. And then let's iterate as quickly as often as possible, because that'll help us get out of these failure modes. Almost all of the failure modes we're talking to relate to some issue here in this wheel of CPMAI.
Exactly. And so it is important to understand, if we say that data is the heart of AI, 80% of your projects are going to be data engineering projects. The first 3 phases are going to take more time than the second 3 phases in each iteration, and that's okay. And also, when we think about starting small, managing scope is incredibly important. As I'm sure many of you know, scope creep is very real and can start making your projects expand in time and complexity. So that's why following best practices like CPMAI really gives you that step-by-step approach that you need to run and manage AI projects in a successful, repeatable way. It has been broadly adopted in both many private sector organizations and also a number of public sector government agencies from around the world since 2017. It is a training and a certification, and it's very detailed and relevant. It's continuously updated and quite in-depth. It gives you a very comprehensive overview. So there are no prerequisites. Anybody can take this. And it really does help enhance your knowledge, your understanding, and it can enhance your career as well, especially if you are looking to run AI projects going forward. So included in this is the certification, the training. We also have a workbook. All training materials and exercise fees are included in our price. If you'd like to learn more, you can go to courses.cognilytica.com and use the code PMI/2024 for 10% off any different CPMAI certification. We offer 3 different levels. We have our CPMAI, which is our core certification. We have our CPMAI Plus, which is enhanced around automation and big data fundamentals. And then we have our CPMAI Plus E, which is our most comprehensive. It has our core CPMAI with the additional in plus, so around automation and big data fundamentals and data science, and then enhanced with our E, our ethics around our trustworthy AI framework. So it gives you many different things to consider to make sure that you're building trustworthy and responsible and ethical AI systems.
Of course, if you just want to learn more about CPMAI, we do have a free intro course to get a little PDUs with that as well. So that comes in the thank you and when you complete the course. But if you just want a good overview of CPMAI, this methodology that we talk about, well, starting from business understanding, which will help you determine the AI specificity of the project, help you identify which pattern or patterns of AI are appropriate for the project, and then help you go through the rest of those phases. You can learn about that at a high level in our intro course. We've put a lot of people through the intro course, so you join a very large community of people. And there's also a lot of people who are CPMAI certified. It's becoming really rapidly adopted, mainly because there really aren't many other alternatives to a methodology for running and managing AI projects. So check it out. You can go to aitoday.live/CPMAI to register for that free course if you're interested, and get a few more PDUs and learn more about CPMAI.
Yep, and we have a QR code as well on this screen. So I'll hang on to this screen for just a minute if anybody wants to go to it.
Yeah, and so we are actually here near the end. We'll provide our contact information, but we do have time for questions. I didn't see any, at least as a panelist, I didn't see any conversations or questions being asked, but we are here for you, and we will be spending. Okay, I actually do see one open question right now, so I think we will answer this for you. So the question is from Jose Miguel Andrinal. Thank you very much for asking. Thank you very much for the presentation. I would appreciate if you could give us thoughts on the ethics in AI, data justice, algorithmic bias. Thanks in advance. Oh my goodness, we have a lot to say about trustworthy AI. We have, in fact, a whole other line of courses, and we have a whole bunch of podcasts which you should listen to. We write a lot about this topic. So it turns out there's many different issues when it comes to trustworthy and ethical, responsible AI. As you can tell, even by the way I'm responding, that there's issues around ethical AI, around do no harm and make sure machines aren't causing financial harm, emotional harm, physical harm, all those sorts of things. Of course, we have issues around data bias, but we also have the issues of responsible use of AI, which is that the technology itself might be neutral, like facial recognition, but you can use that technology in very irresponsible ways. So it's not just the machines being unethical, but it's the people who are just using this technology for not the greatest purposes. And there's lots of things around that: responsible use, issues of data privacy, security and safety, issues around even things like, do you have consent? Are people aware that AI is being used? Do they have any rights to appeal, especially if AI is being used in decision-making? And then we have other layers of trustworthy AI that have to do with things like transparency, visibility into the AI systems. We have governance, which are basically the having actual human levels of control and accountability. And of course, we even have technical things around explainability. Will the system provide answers? So it turns out there's lots and lots of issues, many of which are unresolved. And many of these things have made their way into the EU AI Act. And I'm going to hand it to my partner, who's got a lot to say about the EU AI Act, because we have actually been involved in that as an organization.
Yes, we have. So back in 2020, in February of 2020, right before the world shut down, I went to Paris to present at the OECD, the Organization for Economic Cooperation and Development, on the 7 patterns of AI that we talked about earlier in this presentation. And they have adopted that as their definition of AI. So if you don't know, even though AI, the term was officially coined in 1956, there is no commonly accepted definition of AI. So the EU or the OECD has adopted the 7 patterns as their definition. which is now the definition that is being adopted in the EU AI Act. So we're hopeful that that will, eventually become a global standard definition of AI. But that is why also it's really incredibly important to, just understand the 7 patterns and be able to break things down one level deeper.
Yeah, it's a good question. The answer is yes, of course, because when you're having machines do things instead of people, a lot can go wrong.
Right.
And a lot does go wrong. For every
Oh, yeah.
example we have here, we have like 20 examples. So Carlos, thank you very much. Thanks a lot. Really appreciate that. And also from Santiago, very much. Thank you very much. And Rafael. Yeah, so I think, we are here. If you want to reach out to us, we're available. We're most accessible on LinkedIn. So find us there. I could actually realize our names aren't on this particular slide, so we should probably put them in. But I can send a chat here, but if I do, I'm not sure if it goes to everybody or not. So
you could put it in the question, maybe, or maybe they can't see that. That's just us.
Yeah, yeah, I don't know. I mean, I could type an answer. Actually, I can type an answer here, but okay, there's a question about our podcast. So if you go to AItoday.live,
Yes, right down at the bottom.
Yeah, it'll
too.
redirect you there. So I'll just send a message there. And yeah, I'm Ron Schmelzer, and this is Kathleen Walch. So if you want to connect with us or look up Cognilytica on LinkedIn and look for the people, and you'll find us. So
yes, absolutely. And we do have our podcast at aitoday.live, but we also are on Apple podcasts and Spotify as well. And others, we're on Stitcher and TuneIn as well. So wherever you listen to podcasts, you can find AI Today.
all right. And I want to
Thanks
thank
a lot very much, Ron and Kathleen, for this great presentation. It has been quite interesting and bring a lot of clarity to this incredible AI maze. And we learn a lot really with you guys. I remind you with the assistant, you will obtain one video and we will send you the email with the corresponding code. Again, thanks to all of you. Thanks again, Kathleen and Ron, for sharing your knowledge with this presentation. And we hope you have a good summer vacancy, and we will see you in September. Have a good time.
Thank
See
you
you.
all.
Bye-bye.
Yes, thank you all.
Thanks
And
a lot.
you absolutely can reach out to us on LinkedIn or listen to our podcasts.
Bye-bye. This is your house. See you. Bye.